Today's lesson is over logarithms and logarithmic functions. I want you to notice that y equals b to the power of x can be rewritten as log of y base b equals x. And y equals e to the power of x can be rewritten as natural log of y equals x. We're going to use these relationships later on. For exercise 1, it tells us to rewrite the equation in exponential form. So we're going to use the top property. I want you to write down what each variable here is. So b, the base is 10, x is 3, and y is 1000. Now we can go ahead and rewrite it. And here's my new equation. Now let's move on to number 2. For number 2, our base is 5, our x is -2, and our y is 1 over 5. Now let's rewrite that. So our rewritten equation is 1 over 25 is equal to 5 to the -2. Now I want you to try number 3 and number 4 on your own. For number 5 through 8, we need to rewrite the equation in logarithmic form. So for 5 through 8, they give us this form right here, and they want us to give them this form. So we're doing the opposite of what we did on the top. Once again, I want you to write out your variables. So the base here is 12, our x is 2, our y is 144. Now go ahead and rewrite it. This is our new equation. Log 144 base 12 is equal to 2. Now let's go ahead and try number 6. For number 6, our base is 20, our x is -1, and y is 1 over 20. So this is how you rewrite it. Log 1 over 20 base 20 is equal to -1. Now go ahead and try number 7 and 8 on your own. For 9 through 12, we need to evaluate the logarithm. You can do this by rewriting the logarithm into exponential form. So what we did for number 1 through 4. Let's go ahead and do that. So for number 9, we know that the base is 4, we don't know what x is, and we know what y is 64. So let's go ahead and rewrite it. The only x that we can plug in here to give us 64 would be x equals 3. And you can check that on your calculator. Let's move on to number 10. Let's do the same thing. First, write what the variables are and rewrite the equation. Here, the base is 1/8. We don't know what x is, and y is 1. The only x that you can plug in to give you 1 at the end would be x equals 0, because you know anything to the 0 power gives you 1. And you can check it in your calculator if you want to. Now let's move on. Well, you try number 11 and 12. Let's move on to number 13. For number 13 and 14, they want us to simplify the expression. I want you to notice that this base 13 and log base 13 cancel each other out. They are opposites, so you're just going to be left with 6. Now for number 14, natural log and base e can also cancel each other out. They are also opposites, so you would just be left with x to the 3rd. For number 15 and 16, we need to find the inverse of the function. So for that, remember we swap the x and the y's, then we solve for y. In order to get y by itself, first we need to subtract 10 from both sides. Now we need to get rid of this base 15. So remember, the opposite of this would be to take the log base 15. So log base 15 and base 15 are going to cancel each other out. So on this side, we're just left with y. So this would be our final answer. Y equals log x minus 10 base 15. Now I want you to try number 16 on your own. I know it looks hard, but I want you to remember that the opposite of natural log is e. For number 17, we're going to have to graph and determine the domain, the range, and the asymptotes. So we're going to use Desmos. Go ahead and type in your equation, y equals, you're going to need log base 2, so go to functions, and then log base a, you're going to put that 2 there, then x plus 1. And there's your graph. Remember, if you want points, you can go to edit list and convert to a table. So the only points that are given are 0, 0, and 1, 1. So go ahead and plot those points. First, I want us to notice the asymptote. The asymptote, remember, is what the graph approaches but never really touches. It looks like the graph is approaching the line x equals -1, but it never actually touches it. So our asymptote is x equals -1. That's going to help us figure out what our domain is. So remember, we need to figure out where the x values start. So it looks like they start somewhere at x equals -1 and they never end. So x has to be greater than -1. Now for our range, we're looking at our y values. So we need to see where the y's start. We can't really see where they start. If you scroll down, it keeps going, and you can't see where they end. So the range looks like all real numbers. Now I want you to try number 18 on your own. Remember to use Desmos if you don't have a graphing calculator. And that's it for today's notes.